So I'm just writing. Okay. Just check if it is visible to you. Okay. So we had done free body diagram. First law of motion we were sorting out, in which I had told you about the inclined planes and everything. Okay. Now I am doing one more question, and that is dependent upon Newton's second law of motion. Done?
Yes, ma'am.
Okay. So what does it say? Basically, that the total force applied over any object is directly proportional to the change in momentum over change in time. Correct?
Yes, ma'am.
Yeah. Okay. So basically, what happens here is, suppose this is a particular mass, let's say m1, and here I am having a mass, let's say m2, and it's moving with velocity u, and it is moving with velocity v. And we got a change in the initial momentum and the final momentum. How you will going to show it as mv minus mu over delta t. Done? Or it can also be written as ma. Correct?
Yes, ma'am.
Okay. Any doubts?
No, ma'am.
Great. So after this,
Ma'am, your voice, I can't hear your voice now, ma'am. Like, um,
why? What happened? Is it not audible?
yeah, now I
Now?
can. Yeah, yes, ma'am.
Oh, I
Some
had kept my
stating.
laptop down. Yeah.
Okay, ma'am.
Now is it audible, no?
Yes, ma'am. Yes, ma'am. I can hear it.
Okay, great. So as per this law, what I wanted to convey is, yeah, now have a look over this. Now what do I want to convey is, every time whenever you are solving any question, like I'll give you one question. Let's say I have here a particular fixed table. Done. And here I am having a mass, let's say m. So with this mass m, and where the force has been applied, and here the normal force is acting. Done. Here mg is acting. So how you will going to solve this, as you will draw the free body diagram for mass m, where normal force is acting, it's moving with some force a, and it is moving with some mg weight. Okay. So basically, where the force is being applied, the resultant force, that direction will only act as accelerating direction. Done. So how you will going to solve the acceleration for this type of condition is, first you have to write all the forces which are working. So here the very first force is n equals to mg.
Yes,
Done.
ma'am.
Are you
Yes,
are you
yes,
facing
ma'am.
difficulty, Akshita?
No, ma'am. No, ma'am. Can you hear me?
Yeah, you are perfectly audible to me. Don't worry.
It's just
I
like
have
when
thought
you're
it's not.
speaking, like, there is a little bit lag, and the screen is kind of like sometimes it's freezing and then again coming back, like, when you are writing.
Oh, so from your end also it's somewhere breaking.
Yes, ma'am.
I got it. When you speak a very fast wala thing, then it happens like it gets sticks. Yeah, I know. That is happening from your end also. No issue. Check. So I'll go slow. Okay, Akshita?
Yes, ma'am.
Done. So therefore, I have got that my n is equal to my mg. Done. So therefore, even I can write that what are my total forces which are acting on it is F equals to ma. Done.
Yes, ma'am.
Okay. So the value for n is mg, and the value for acceleration is F over m for this particular situation. Understood?
Yes, ma'am.
Great. Now, accordingly, let me do another question also. One by one, I am doing the question. Just do let me know if you are not able to understand. Now, I'm taking a little bit a tricky question. Here is a mass m which has been pulled with some force F, and it is acting at some theta angle. So, the question is, find n and acceleration of the body. Okay, done. So
Yes,
what happens here is, question is we have to find n and a. So what you will do is, we'll find out all the forces first. So here it is mg, here it is normal force. Correct.
yes, ma'am.
And here, as the horizontal direction is there, therefore this will be f cos theta, and here it will be f sin theta. Correct?
Yes, ma'am.
Okay, now you have drawn the FBT. So after that, you will equalize the x and the y forces. X and the y forces. This is acceleration direction. Okay, listen step by step how you will solve. So you have to write first x and y forces. I have written n plus f sine theta equals to mg. So I got my normal force mg plus, sorry, mg, it should be minus okay, let's not just waste the time. It's not getting rubbed. I don't know for what reasons. Okay. So it will be F equals to what? mg minus f sine
Sine
theta. Correct?
Yes,
Understood
ma'am.
now?
Yes, ma'am.
Great. So after that we have, this question. Okay. And that is, yeah, let's come to the next type of force, and now the next force is this which is remaining. Okay, so what it will be, it will be somewhere like this, that your f, I should say cos theta, is equal to ma. Correct?
Yes, ma'am.
Okay, so therefore my acceleration will be f cos theta over m. Making sense, Akshita?
Yes, ma'am.
Great. So anything you would like to ask?
No, ma'am. Can I just copy the diagram for my reference? Just
Sure.
1 second.
Yeah, sure. Yeah. You need the notes also, na? I will inform her that she will give you the exact notes. She is telling me that she will give you the recorded classes. Don't worry. Okay?
Yes, ma'am. Yes, ma'am.
Don't worry about that.
Mm.
You take a snapshot. That would be much better.
Okay.
Yeah, that will save your time as well as mine also.
Yes, ma'am. Done.
Done? Okay.
Yes.
So let's come to the next thing, and that is your next question. So I am taking the next question, such as, like, suppose here I have a thread, and here I am tying a mass of, let's say, 5 kg, and here I am tying a thread. Why it does not have any eraser? Because it's not getting crossed. Some issue is there in this. This eraser is not working for this.
I think maybe we should download the like the actual app in the settings.
Yeah, that otherwise time waste will get wasted. Perfectly fine. Check here. So I have a string over here. Like that. I have a string over here which is having an angle of 30 degree with the horizontal, and this is my 20 Newton of the force. Here I have one more horizontal where I have a 60 degree of the force, and the force is here 10 Newtons. Done. So we have to find out now that what is N and A of the body. Done. So how you will going to do that? It's very easy. First, this is a slant force. This is also a slant force. Let's solve the forces first. Done. So how I will solve the force? Here I will be having a 5 kg of the mass. Okay. Now next. Here is my 20 Newton. Done. Here is 30 degrees. So I think this will be 20 cos 30. Here will be 20 sine 30, right? Correct?
Yes,
You
ma'am.
have to draw one above, one below the arrows. Understood how you will draw?
Yes, ma'am.
Any doubts now?
No, ma'am. Till now it's clear.
Great. Okay. So now if it is here, suppose if it is 10 Newton, so one above you will draw. Okay. And one below you will draw. How you will draw? Where it is carrying the angle. Here it is carrying the angle. So this is parallel to this. So that means this is alternate interior. This will be the same angle. Correct?
Yes, ma'am.
Akshita? Yeah,
Yes.
you will always need the angle at the vertex of the mass, not anywhere else.
Yes, ma'am.
Okay. You have to make the angle in such a way that it should respond. Okay, in the same alignment only. So here I have 10 cos 50 degree and here I have 10 sine 50 degree. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
Okay, it is 60 degree.
Yes, ma'am.
Sorry, my bad. It is 60 degree. Yeah. Okay. Otherwise, it's fine. Anything like to ask?
No, ma'am.
Yeah. Again, the question is the same. That find n and acceleration. Done. It's written already. So let's just find out how you will going to do it. So I will do it. First, I will solve for the normal direction, and here is my normal direction. That is n plus 20 sine 30 will be equal to it is 5 kg, no? So it is balancing this angle and that is 50. Correct?
Yes, ma'am.
Correct? Done.
Yes, ma'am.
So it is equal to 50. Done. And I guess not equal to here, but it will be somewhere like if it is here 50, it will be plus 10 sine 60, right? Which is balancing 50. Correct?
Yes, ma'am.
These two forces plus n normal balancing mg. Making sense?
Yes, ma'am.
Okay, great. Now, look over here for the direction. 20 cos 30 is balancing 10 cos 60. Correct?
10 cos 60. 20 cos 30, 10 cos 60. Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. Now, one thing is the object is aligned to be accelerated in this direction. Okay. Then what you have to do is, Akshita, please don't write equal to. Then what you have to do? You have to write total number of forces equal to ma. So what are the total number of forces? Acceleration direction will be positive and non-acceleration direction will be negative, which will be equal to ma. Understood?
Yes, ma'am.
Any doubts? Sorry.
No, ma'am.
Which be equal to ma. Correct?
Yes, ma'am.
Okay. Now with this equation and this equation, you can find the value of n and a. Equation in two variables. This is now simple mathematics. Can you do it ahead?
Yes, ma'am.
Are you sure? Or shall I do it for you?
No, ma'am. I can do it in my. We can use the calculator, right? This is paper
Yeah,
2, I guess.
obviously.
Yeah.
Not
Yeah. I
your
kind
time
of
will use.
thought it's.
See, the graphical thing is not allowed, but other than that, scientific calculator is definitely allowed. Okay, we will not waste our time over this. Also, I'm moving ahead.
Minus.
Or do you in 2 minutes?
I'm getting this as.
Yeah, please.
Minus 5 plus.
N equals to
12.32. 12.32. Which
N
will be
equals to
12.3. 12.3, ma'am.
okay. I have
Can
written normal force 2.3. Correct. Yeah. Yeah, you are audible. Hello.
Hello, ma'am.
Yeah, you are audible.
Oh, from my side, I
Am
think
I
my
audible?
internet connection is weak. Your voice is extremely like breaking, ma'am. Like, it's like bit by bit I can hear you, but I can't hear you clearly.
Wait.
I will also rejoin, ma'am. 1 second.
Yeah, that is what I'm doing. I'm reading the class.
Ma'am, can you hear me now? Hello, ma'am. Actually, I can't see the screen, ma'am. Ma'am, can you hear me now?
Yes, Akshata, I can hear you.
Yes, I can also hear you clearly now.
Okay, is it audible now? Everything?
Yes, ma'am.
Okay. Just wait. I'm just sharing the page. Is it visible now?
Yes, ma'am. I can see now.
Okay. Okay, very good. Done. So like this, what I had written. Yeah, you were calculating the values, right?
Yes, ma'am. It
Okay.
was 12.3.
12.3. Okay.
Yes, ma'am.
You have sorted the normal force, right?
Yes, ma'am.
So 12.3 newtons you have sorted, and it was actually n plus 10 sine 60 plus 20 sine 30 equal to 50, right? This was the equation.
Yes, ma'am.
Done. Now the next equation, as I had told you, it will be 10 cos 60 equal to 20 cos 30. Done. But we do not have to write this. As I had told you, what you have to write is, you will write acceleration direction as positive, non-acceleration direction as negative, and then after that you will write cos 60, you will write equals to ma. This is what is the change in first to second. Understood? This is first law, Akshita. This is
Yes,
second
ma'am.
law. Check what I have shown you the change. This is moving in this direction, in x direction, moving in this direction. Hence, these two forces are equal to each other. So this is my first law, that how I will denote. Understood? You have to equalize the two forces. Then second equation, what you have to write, where it is accelerating. So where it is accelerating, that thing you will show where accelerated direction as plus, non-accelerated direction as minus, equal to ma. Understood, Akshita?
Yes, ma'am.
Now any doubts?
No, ma'am.
Are you sure?
Yes, ma'am.
Okay. So I am from my end, I am thinking that you are getting this point. Okay. So the very first thing that you will do is you will draw the FBD. Okay. After drawing FBD, you will
Yes, ma'am.
write first the Newton's first law of equation wherever is been applied. If it is applied in X, you will write the X direction first. If it is applied in Y, you will write the Y direction first. Understood?
Yes, ma'am.
Okay. After that, you will write the MA direction. So in MA direction, you will not allow this formula, but you will do what? You will subtract the non-accelerated from accelerated, because the formula tell me that total force which is applied is MA. So which is the total force applied? This is the total force applied, right?
Yes, ma'am.
This force minus this force will be the direction where the acceleration is happening. Correct?
Yes, ma'am.
Any doubts now?
No, ma'am.
Are you sure?
Yes, ma'am.
Great. Now I'm moving ahead with the next question, and here is my next question. What is the next question? Suppose I have here the 2 kg mass. Suppose I have here the 3 kg mass. And suppose I have here the 4 kg mass. Now what is happening? They all are settled at one fixed floor, and this is accelerating over this is accelerating over this is accelerating over this. Understood?
Yes,
All
ma'am.
are accelerating. So the question is, find the acceleration of all the blocks and n between 4 kg and 3 kg block. Done? Now listen very carefully what is happening. I am drawing the FBD first for 2 kg mass. FBD for 2 kg mass will be here. It is applying how much of the force? Okay, from here I am applying a 18 Newton of the force. Understood?
Yes, ma'am.
Great. So for here 18 Newton is applied for 2 kg if I give a push, and in this direction my normal force is applied.
Yes, ma'am.
Great.
Yes, ma'am.
Going ahead, if I draw the FBD for this, then 18 Newton is the positive direction, N is the negative direction, correct? Which is
Yes.
equal to MA. MA here it will be 2A. Making sense?
Yes,
Akshita?
ma'am. Yes, ma'am.
Great. Now therefore I can rewrite it as 18 minus N is equal to, sorry, I can solve this now, na? Why to write this one now? So what I can do is I can write it as, okay, let it be our first equation. Let's see the next. There I can get some answer. So in 3 kg, here I am having the N of the force for 3 kg. This is applying a force in this direction, and the same way this is applying the same force in this direction, that is N. Therefore, this N is applied over this. Making sense?
How, ma'am? No, ma'am. No, ma'am. I am not understanding this part.
Okay. I'm explaining you. Don't worry. I'm explaining you this part. Okay. Check. This is my 2 kg.
Yes, ma'am.
With this 3 kg is connected.
Yes, ma'am.
When I apply acceleration over here, that means acceleration is going this side.
Yes, ma'am.
So this acceleration will apply equal and opposite force, that is the normal force.
Yes, ma'am.
Okay, so 2 kg block is applying a normal force over this. Okay, that means this acceleration now is equal to normal force.
Yes, ma'am.
Making sense?
Yes, ma'am.
Great. So this normal force, that means it is acting now on the second block.
Yes, ma'am.
If I am standing on the earth, I am applying weight. The weight will apply equal and opposite direction force. That is normal force, right?
Yes, ma'am.
This normal force is weighted on weighing machine, you observe.
Yes, ma'am.
Right? So if
Yes.
here it is applying a normal force, that means in this direction it is applying a normal force. Where is the acceleration for 3 kg? In this direction. What is the value of acceleration? Normal. Getting?
Yes, ma'am.
Any doubts now?
No, ma'am.
Sure?
Sure, ma'am.
Sure. Okay. So that means this will apply equal and opposite force over the here. Let's say it is applying N1 force. Correct?
Yes, ma'am.
Okay. So let's collect the next one. This is 4 kg. This N1 will now is nothing but your N. Hence this N1 force will be applied on the 4 kg now.
Yes, ma'am.
Are you getting? See,
Yes.
started from here, I had applied 18 Newton. This 18 Newton, when I had applied here, it had equal and opposite force it had applied here. That means mine now 18 Newton is nothing but this normal force. Okay?
Yes. Yes, ma'am.
Okay. So when I come to 3 kg, my 18 Newton force is applied on 3 kg only, na?
Yes, ma'am.
That means my 18 Newton is normal force only, na?
Yes, ma'am.
That means it is applied over here, normal force.
Yes, ma'am.
Which is balancing again equal and opposite force of N1.
Yes, ma'am.
Okay. Now this N1 force, that means it is behaving as the next force for this object also.
Yes, ma'am.
Getting? Now any doubts?
No, ma'am.
So
No, ma'am.
I'm drawing 3 FBD, 18 Newton here, and let's say N force over here for 2 kg. Second FBD, I'm drawing over here, which is my N is nothing but my N1 for the 3 kg. Okay, and which is my N1 now is nothing but, I guess this is for 4 kg. Correct?
Yes, ma'am.
Now any doubts?
No, ma'am.
Started from here now, being very quick. 18 minus normal force is equal to my MA. First equation. Correct?
Yes, ma'am.
N
Yes, ma'am.
minus N1 is equal to my MA.
Yes, ma'am.
Correct? And
Yes, ma'am.
N1 equals to my MA. Second equation, third equation.
Yes, ma'am.
Any doubts?
No, ma'am.
Great. So we are starting from here. My N1 is MA. Apply it in this equation. Therefore, N1 minus what is MA? This is 4 kg. That means 4A. So 4A is equal to, this is MA. MA is for this. This is 3A. Correct?
Yes, ma'am.
Very good. Now my voice is not merging now.
No, ma'am. No, ma'am.
Great. So therefore I got the formula over here that my N equals to 3A plus 4A. Correct? So my N equals to
Yes, ma'am.
7A. One thing I got here, one thing I got here. Let's apply it over here. So here my N is how much I got? 7A. Apply it over here. 18 minus 7A is equal to 2A. So 18 will be equal to 9A. Any doubts?
No, ma'am.
Sure.
Sure, ma'am. Sure.
I got the value of A, 18 over 9 equals to 2 meter per second square. Acceleration I got, I will apply it over here. So I got 7 into 2. That means 14 Newton is my first normal force. Got it?
Yes, ma'am.
Akshita, any doubts?
No, ma'am. No, ma'am. I can understand now.
I'm doing simple maths, okay? Don't get
Yes.
stuck. So
Okay.
my N1 is equal to 4 into A. Okay, what is the value of A? Again, it is 4 into 2. Therefore, my N1 will be equal to 8 newtons.
Newton. Yes, ma'am.
Understood the complete theory?
Yes, ma'am.
Any doubts now?
No, ma'am.
Great. Now I am doing it for the pulley system. Sometimes you get the question over pulley system also. Done. So what is the formula for pulley system? Suppose this is my fixed end and here I am tying one pulley and here I am having two masses. Let's say here I am having a mass of 5 kg and here I am having a mass of 2 kg and here I am having a mass of 4 kg. Done?
Yes, ma'am.
Question is find acceleration. Any doubts?
No, ma'am.
Great. Moving ahead, just have a look over here. I think this will apply 5g in the downward direction. This will apply a 6g in the downward direction. Correct?
Yes, ma'am.
What is the acceleration formula? F over m?
Yes, ma'am.
Okay, let's find out the total forces. Total forces, higher force, I guess, is this because the acceleration is going in this direction over here.
Yes, ma'am.
Correct? It is a
Yes.
two body system. So this is putting the acceleration. And here the acceleration is going in the upward direction. Correct?
Yes, ma'am.
Yeah. So I think it will be 6g minus 5g over mass is how much? So I should say 4 plus 2 is how much? 6. 6 plus 5 is how much? 11.
Yes, ma'am.
So I got my answer as 10 over 11 meter per second square. You can solve it afterwards. What is 10 over 11? Done?
Yes, ma'am.
Okay, let's do the next expected question that is coming in your exam. So if suppose this is my fixed terminal, okay, and here I am having a mass, let's say 5 kg, and it is been tied with your pulley like this, and here I am tying another mass, let's say 1 kg. Done. So here I will
Yes.
apply a 1g of the force. Here will be the tension force. Okay. And now
Yes.
again the same tension force you will find it over here. Here I will be having normal force. Here I will be having mg force. Anywhere doubt?
No, ma'am.
Great. Where is the acceleration happening? It is happening in this direction. Now let's solve. Shall I?
Yes, ma'am.
Great. So I guess my 1g minus t is nothing but the acceleration, correct?
Yes, ma'am.
Okay, let's come to 5g. So normal force is equal to 50 newtons.
Yes, ma'am.
Great. So this will be happening acceleration over here in this direction.
Yes, ma'am.
Okay, so the tension direction and the MA direction is same. That means my tension is equal to MA. So that means my tension is equal to 5A. Correct?
Yes, ma'am.
I'm applying this over here. So I am getting 1g plus. Sorry, not plus. Is it a plus? No, something. It's a minus. My bad. Sorry. Equals to A. Correct now?
Yes, ma'am.
Okay, great. It will go there. So that means my 1g equals to 6A. So what is your acceleration? Acceleration will be 1 over 6g.
Yes, ma'am.
Any doubt, Akshita?
No, ma'am. I'm just like thinking of the last part. 1 second, ma'am.
Huh?
Yes, ma'am. Yes, ma'am.
Think. It's okay.
T. And then we are going to find T after applying the A and the T.
Yeah, you apply this value of A over here. 1
Yes,
by
ma'am.
6 of 10. G is 10 or 9.8. You will get
Yes.
one value. Done.
Yes.
So
Yes.
this value when you are applying in this equation, okay, so you will get the answer for tension also. Okay?
Yes, ma'am.
Yeah, any doubt?
No, ma'am.
Sure?
Sure, ma'am.
Done. Very good. So next is Newton's third law of motion. Okay, what does the motion, this law conveys? That whatever action we have, okay, that will be equal to reaction. Thing to be noted
Yes.
as both are acting on different objects. They does not act on same object. Like I can give you one example. Here I have a block of mass m. From here, a person is pushing it, and from here, the same force is applied, and the next person is pushing it. Let's say 10 Newton, let's say 10 Newton. Hence, the object will be at rest, and there will be no resultant force.
Yes,
Correct?
ma'am. Yes, ma'am.
Am I making sense?
Yes, ma'am. Yes, ma'am.
Okay, there will be no resultant force, or there will be no resultant moment. This is the IB board says. Okay, so
Yes, ma'am.
basically, if suppose I have here the wall and I have the ball in my hand and I push it over here with some velocity, say u, okay, it will come back with the same velocity v, right? Now, why the action is happening and why the reaction is happening, whereas I am applying the same forces? So the factor is, while going, ball is applying the force over the wall, whereas while coming, the wall is applying the force over the ball. Hence, here you can see the work done, and here you cannot see the work done. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
This law tells me a very important factor, that the force always exists in opposite direction. Done?
Yes, ma'am.
Okay. Anything you would like to ask?
No,
Mm-hmm.
no.
Sure?
Sure.
Yeah, these are the basics that we do study in the earlier classes.
Yes, ma'am. Yes, ma'am.
Okay. Yeah. Going ahead, I have the next question, and that is, yeah, check over here. Suppose this is a fixed terminal, and over here a rope I am tying. This rope is hanging in such a way that a monkey is trying to jump over this. Okay. When a monkey is trying to jump over this, what happens is the acceleration is found to be 2 meter per second square. Okay. The monkey is of 20 kg. Okay. And the G is been applied in the downward direction, which is 10. Right now, I am taking all the standard cases only, so that we can do the question answers at a hurry pace. Done?
Yes, ma'am.
Wherever it is written 9.8, you can use 9.8 also. Okay, in exam.
Oh, yes,
So
ma'am.
you have to find the tension in the string. Okay, so you have to find the tension in the string. What you will do? Apply the same formula. Where the acceleration is happening? Over here?
Upwards. Yes, ma'am.
Upwards. So that means upward direction is plus, downward direction is minus. Any doubts?
No, ma'am.
Total force I have to find. That means I am doing T minus mg.
Yes, ma'am.
Any doubts?
No, ma'am.
Which is equal to your ma. So here my T is nothing but mg plus ma. So this defines me a very simple thing also, that whenever I am going up with my weight, another additional mass also gets added to me, another additional force also gets added to me. Hence I feel very much weighted when I go up. Example I can give you, like when you go in the vertical swings, that is known as marigold. Have you
Yes,
ever
ma'am.
gone the vertical swings like this?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
The chairs are like this over in this.
Yeah,
So when you go up, you feel very much weighted. When you come down, you feel very much weightless. Is
but
it
like I
happening with you?
always like when we are learning it, I learned this, but then when I'm actually experiencing it, I'm not experiencing anything. Like I just feel normal. I don't know why.
You feel
Maybe I should
normal.
try once again with this.
Yeah, I can
Kind
give you
of
example. I can give you one more example. With your friend, when you do this wala thing, they hold their hands
ah
and they swing
yes, ma'am.
round and round. Okay.
Yes,
So
ma'am.
when you do this thing, you always feel like you will fall outward. You will fall
Yes.
outward. If you leave the
Yes.
hand, you will fall outward.
Yes, ma'am.
Okay. And if you do not leave, you feel weighted.
Yes, ma'am.
Does it happen now, Akshita?
Yes, ma'am. Yes, ma'am.
When you leave the hand, it's always scary that you don't want to leave your partner's hand
Yes, ma'am.
because you are aware that I will fall outward.
Yes, ma'am.
But again, when you are doing this round and round, you feel like you are having some extra mass with you
Yes,
that you
ma'am.
have to carry while doing
Yes.
round and round and round. So you feel so weighted.
Yes, ma'am.
Okay. So whenever you are in the simple concept over here is whenever you are in a moving frame of reference, additional mass gets added to you or it gets subtracted. Hence, sometimes you feel weightless, sometimes you feel extra weighted. Okay.
Yes, ma'am.
One more example, if you need, I can give you. If you are standing in the elevator and if it is going up, then also you feel somewhat weighted. And when you are coming down, suppose I cut the rope off here and it is freely falling, you will feel like your head had got touched with the roof of the elevator,
Yes,
but
ma'am.
the elevator is going down. So my question is why your foot is not touching the bottom of the elevator? Why your head is touching this?
Because of the acceleration,
No, because my acceleration becomes added with
the weight.
this. Yeah. So hence my acceleration becomes double of this.
Yes,
Near,
ma'am.
not double, but I should say a more value than this. Right?
Yes, ma'am.
So your small g is 9.8, the highest acceleration with which you can freely fall. But your lift is accelerated with some extra acceleration. And hence you will feel like my head had got touch over here. And as soon it will crash, my speed will be more.
Yes, ma'am.
Okay, fine.
Yes.
Understood.
Yes, ma'am.
Okay, so coming back to our topic here, I have mg. G is 10, mass is 20, so I guess it will be 20 into 10, which is nothing but 200. Mass is again 20, acceleration is 2. So 20 into 2 is 40. So here I
Yes.
will get 240 newtons tension in the rope.
Yes, ma'am.
Okay, so equal and opposite force. So sometimes what happens, there is a tension of the rope where that it can carry suppose only 1000 kg, and now you are trying to hang more than 1000, let's say 1030 kg. So it will beep in the elevator that you are overweighted because it
Yes.
cannot carry above of this tension.
Yes,
Okay,
ma'am.
if it is not able to carry, it will break.
Yes, ma'am.
Okay, so this type of question also come in exam.
Yes, ma'am.
Okay, now conservation of momentum is a very very easy topic. Still I will give you one example. Okay,
Yes.
suppose I have conservation of momentum, you are aware,
Yes, ma'am.
or shall I write it for you?
No, ma'am. No, ma'am. It's fine. I think I
Yeah.
know the. I don't like. I. One second, ma'am. I'm trying to remember the law.
Hmm.
Energy can be neither created nor destroyed in a.
That
That.
is energy.
Oh.
I'm asking momentum.
Okay, ma'am. I know the
Okay.
formula. It will be mv minus mu, like mu minus mv. Some
Check,
m.
check. I'm writing. It's okay. It's okay. Relax. So this is the formula. Basically, it says the momentum before the collision will be equal to momentum after collision.
Yes, ma'am.
Done. So this is the law. Okay. Now let's come to the main part of this. How do we do this? So I'm taking one question over here. Let's say I have a bomb and here I had broken it. Okay. So what happened? It had got broken into 1:2. Then
Yes.
5 meter per second speed it had acquired, and let's say it had acquired some velocity, let's say v. Okay, so the
Yes.
question is, if the f net over this is equal to 0, then what do you think? P is obviously conserved. First thing is to that.
Yes, ma'am.
Okay, what do you think, what will be the velocity?
The velocity will be
Okay, let me do it. This is pi equals to pf. First thing,
yes, ma'am.
p is the momentum,
Yes, ma'am.
Okay, initially when you start to throw the bomb, basically it is 0 at
Zero.
rest.
Yes,
All the
ma'am.
things are 0. PF, let's continue with PF. Okay, so mass into velocity is the formula.
Yes, ma'am.
Mass into velocity is the formula. So here, if it is double of the mass and here it is single of the mass, because the ratio is 1:2, done. So
Yes,
I
ma'am.
can take it as that my 2m mass is running with 5 meter of the velocity, whereas my 1 meter mass is running with some velocity. So I got 1 mv is equal to 5 2s are 10 m.
Yes, ma'am.
M and M got cancelled. I got my velocity as 10 meter per second.
Yes, ma'am.
Making sense? Any
Yes, ma'am.
doubts?
No, ma'am.
Sure.
Sure, sure, sure.
One last point in this class. What is spring force? So basically spring force is what? F equals to minus kx,
Minus kx.
where k is the spring constant,
Yes, ma'am.
which is different for every spring, and x is the extension in the spring. Extension could be both. It could be compression,
Compression or the
elongation.
expansion.
Done. So you
Yes.
can calculate any of the two. Now what happens is, suppose I take a question as, here I have a mass, let's say B, which is tied with a spring, let's say A, and here I am tying it with the K constant as 100 Newton per meter. Done, and it is kept over a steady surface. Now, question is, find the spring force. Obviously, if both I am replacing, let me write it for you clearly. So question is, find the spring force if both are displaced by 1 meter each. Done?
Yes, ma'am.
Okay, very good. So after this, I am displacing. Question is, it could be in the same direction or it could be in the opposite direction. Okay, now let's have a look. If suppose I'm talking about same direction, if I pull this 1 meter, this will also be pulled 1 meter. Making
Yes, ma'am.
sense?
Yes, ma'am.
Okay, so the net spring force which is acting over this is 0.
Yes, ma'am.
Correct? Let's pull them in the opposite direction. If I pull it in the 1 meter direction over here, this will be pulled 1 meter direction over here. So how much it got pulled? 1 plus 1, 2. Correct? So net elongation is 2 meters. You can find F equals to kx. So F is 2. K is given as 100 multiply x. So x you can find it out as what? Oh, something is wrong I had written. Force we have to find, no? Sorry, my bad. I had written wrong. So force we have to find. K is given as 100. Elongation is of 2. So this will be 200 newtons.
Yes, ma'am.
Akshita, any doubts?
No, ma'am.
Okay, my humble request to you, from tomorrow onwards, please join the class on time. Okay?
Yes.
Tomorrow, as I am having a function in my school, so I am taking a class in the morning schedule, that is 10 a.m. Okay?
Yes, ma'am.
Oh, please join the class on time. Okay?
Okay, ma'am.
Okay. And if you have any doubt in this class, please bring it to me beforehand and we can discuss it in the first 10 minutes. Done?
Yes, ma'am.
Okay. Bye, Akshita. Have a nice day.
Bye, ma'am. Thank you, ma'am.
Yeah, bye.